Recently, the Dutch government supported further tightening U.S. export controls on China. Yet 10 days later, a high-level Dutch delegation was rushing to Beijing. The group included 17 tech companies, led by executives from the lithography giant ASML. The visit followed years of escalating pressure from Washington, urging the Netherlands to restrict the export of advanced chip-making technology and using decade-old laws to target firms like Nexperia. This arrival in Beijing represented a crisis response, driven by the fear of losing their largest and most vital customer base as it detaches from the Western ecosystem. ASML's lithography machines are the absolute choke point for advanced manufacturing. These systems use light to print microscopic circuits, a process so complex that it has long been considered impossible to replicate without Dutch hardware. Financial forecasts show a stark divergence. ASML's revenue share from China is projected to drop from 36% to 20% by 2026. Yet ASML CFO confirmed shipped equipment is installed and Chinese factories operate at full capacity. This creates a paradox. Chinese factories are maintaining high-volume output while buying less Dutch equipment. They are likely altering the core methods of high-performance chip production. The traditional path to performance relies on shrinking transistors to microscopic scales, a physical limit that strictly requires ASML's most advanced machines. Blocked from that hardware, China is pursuing a third path, bypassing the need for smaller transistors through architectural innovation. The DF1000 AI chip utilizes an unrestricted 14-nanometer process, yet reaches 520 trillion operations per second. This near-in-memory computing places processing power adjacent to data storage, reducing the need for restricted high-capacity components. By redesigning the physical architecture of the chip, engineers have made the nanometer bottleneck irrelevant for specific high-performance computing needs. Simultaneously, an 8-inch two-dimensional semiconductor engineering line has become fully operational in Shanghai. The roadmap for this technology is aggressive, with plans to launch commercial foundry services by 2027 and reach a 5-nanometer equivalent process by 2029. This entire production timeline is being engineered to function without ASML's extreme ultraviolet lithography machines. The sanctions failed to freeze Chinese technology. Instead, they catalyzed a jump into the next generation of semiconductor physics. Spending patterns are already shifting. Within the next year, the proportion of domestically produced AI chips in Chinese procurement budgets is expected to rise from 30%. Achieving high yield rates and long-term stability for these intricate components remains a step-by-step process. Despite those hurdles, the structural shift away from reliance on Western hardware is firmly established. The long-term danger for the West is the successful commercialization of an entirely separate, self-sufficient ecosystem. The 7-year containment strategy produced a significant irony. The pressure intended to halt the industry instead acted as a catalyst for rapid lateral innovation. While the blockade was intended to maintain perpetual leverage, it has instead incubated a competitor that no longer needs to follow the Western technological roadmap. Dutch executives are confronting the possibility that their technology will become irrelevant to the Chinese supply chain. The delegation rushed to Beijing because they recognized that the attempt to build a wall around the future had forced China to build its own doors.